This video is a continuation of Curvy Area Part 1. So in this video, we're going to be doing these 4 examples together. And then next time I see you, or on Friday when I see you in class, I'll be practicing problems somewhat similar to this. So let's start with example number 1. These problems are going to get slightly more difficult as we go. Number 1 is the most basic one. So let's look at number 1 here. It says find the area between the two curves, the y-axis, and x equals 1.5. Now I've already actually shaded the area for you, but whenever you read a problem here, you always want to think for a minute and get an idea of what the boundaries are. Like, where is this actual area? So I went from between the curves. The y-axis, you have to think, okay, the y-axis, what x value does the y-axis have? It has an x value of 0. And then I'm going all the way over to an x value of 1.5. So I'm trapped in this shaded area here. And then you want to be thinking what curve is on top and what curve is on bottom. Because I remember I always do the integral of top curve minus bottom curve. So you can't set this up until you know what the top and the bottom are. In this case, f of x happens to be my top curve and g of x happens to be my bottom curve. And that doesn't change as we go from left to right. So all I'm going to do is set up my integral here. I have the integral. Instead of going from a to b, my leftmost x value is 0. My rightmost x value is 1.5. Also, by the way, on your half sheet, I realize there's hardly any room right here. Do this maybe on the page next to it or at the bottom of the page so you're not squeezing this work in right here. Okay, anyway, so from 0 to 1.5. Now I'm going to do my top curve, which happens to be f of x. So x squared plus 2 minus my bottom curve, which is 1 minus 1 half x dx. Now notice I have parentheses around each of these. Those are going to be very important. And when you type it into your calculator, you need those parentheses or else you're going to get the wrong answer. If you want, you can distribute the negative before you type it into your calculator. If you really want, you could simplify, but to save time, it's probably better just to type this right into your calculator. So on your graphing calculator, which you should have in front of you, what I want you to do is go to Math 9, type into here exactly what's in front of you here. Again, remember the parentheses, and put down what the answer is to 3 decimal places, and then we'll check tomorrow to make sure you got the same thing. For number 2, so pause the video now, type that in your calculator, get an answer, and then I'll move on to number 2. Alrighty, number 2 is a little bit different because notice all it says here is find the area between the two curves. It doesn't tell you anything about like from this x value to this x value, and that's because you have to find those x values yourself. So the area between the two curves runs from where they intersect here, so this x value, and where they intersect here, that x value. Sometimes you're going to have to find your own endpoints, and that's the beauty of the graphing calculator because it makes it easier. Sometimes you can do it by hand. Like the next one, I'll do it by hand. It's actually quicker. But in this case, we need to find out when the curves are equal to each other. So when does h equal g? Because that's the intersection point, and that will give you the x values right there. So I'm going to do calc intersect on the calculator, and it's going to be very important that we store the values. So I'm not going to do any rounding until the very end because sometimes if you round ahead of time, it'll give you the wrong answer at the end and you'll be off by so much that you'll get the answer wrong. So on your graphing calculator, do this with me now. Let's clear this guy out. And in y equals, why don't you type in what f is and what g is. And then go ahead, and I did zoom standard. And here is my parabola, and here's my line, and I want this area here, okay, shaded in between. So I'm going to need my intersection points. So let's go to calc intersect, and I'll pause it. All right, so your cursor should be close to the left endpoint, and I'm going to hit enter 3 times. And here's my first intersection point. So when you do it on your calculator, you're not going to use a rounded value. You're going to use this entire exact answer. And in fact, it's not even showing all the decimal places right here. You'll see that in a minute. So I'm going to store it. Let's go to our home screen and let's do store. Your calculator remembers the last answer it found, which was that x-intercept. I'm going to store it in for A because it's my leftmost endpoint, and we've been calling that A. Also, it's more convenient. There we have it. You're going to need to, on your paper or even on the AP exam, especially for your responses, write down this whole number one time and label it as A, and from then on you can use A. So now go back to your calculator and find this intersection point. So I've moved my cursor over here. I'm going to hit enter 3 times. And I get this intersection point. Again, we're not rounding. We're going to our home screen. Our calculator remembers the last answer it found. So I'm going to hit store. So hit store on your calculator. If you're just watching me do this, it's likely that you're going to forget this. So make sure you're actually doing this on your calculator. Practice makes perfect. And let's store it in for B because we've been calling B the rightmost point. And you're going to need to write that down one time on your paper, and from then on, you can use B. So now let's go back to this problem here, and we're going to call this x value A, and this x value B. So on the AP exam, you would have to tell the reader what these answers are. I hope I'm writing this down right. I think so. And from now on, we're going to use A and B. 1966. Alrighty, so we're going to do the integral, and I want top minus bottom. So let's be clear on what the top curve is. This here is definitely the top curve. This here is definitely, what am I writing? This is definitely the bottom curve. And this curve stays on top the whole time. This curve stays on the bottom the whole time. This top curve is not H, even though H is actually pasted on top of G here. This curve is G. G is on top the whole way across, and H is on bottom the whole way down here. So I need to do G, well, first of all, let's say from A to B, and I'm going to do 3 minus x minus the bottom curve, which is my parabola, x squared minus 8 dx. So go on your calculator and type this in. So you're going to go here and you're going to go to Math 9. Type in your answer exactly as you see it right here, or type in your thing you want to find, I should say, not your answer. And I want you to get an answer rounded to 3 decimal places. Our answer hasn't been rounded yet if you actually stored your values. We're not going to round until the very, very last step. So pause the video and get your answer. Okay, number 3, 2 more. Number 3 is a little bit different here because notice that my curves intersect not at the end points like they did here, but actually almost like right in the middle of what we're talking about. Also, please be aware of the scale here. Every tick mark is half along the x-axis, and on the y-axis they're just normal ones. So what we need to do is find the intersection point. Don't just assume that the intersection point is 1, 1. You should actually find it. You could do calc intersect, or I found it easier. I did feel like doing calc intersect. I just set my functions equal to each other. So I set f and g equal to each other. I solve for x. They intersect at 1, and they would intersect over here at -1. Obviously, I only care about 1. So I know that they do intersect at this x value. And we're going to have to break it up. And the reason we're going to have to break it up is because for part of the area, let's see, this one is G. G is on top, and F is on the bottom. But then for the other part, F is on the top, and G is on the bottom. So I would recommend labeling the curve as you go, especially if this is going to be confusing for you or you think you might make a mistake. And we're going to set up 2 integrals here. And I'm going to go from 0 to 1 and then from 1 to 2. So my second integral will pick up right where the first one left off, from 0 to 1. From 1 to 2. Now when I'm going from 0 to 1, my top curve is G, which is 2 minus x squared. So I'm under the top curve minus the bottom curve, which is x squared. X squared dx. And I'm going to add on to it. So this gives me the area here. Okay? I want to add on to it the area here. And for this area from 1 to 2, my top curve happens to be f, which is x squared. So I'm going to take x squared and I'm going to subtract the bottom curve, which in this case, in this interval, is 2 minus x squared dx. So this integral gives me this chunk right here. So what I want you to do is type this into your calculator. Again, we're doing Math 9 on the home screen. You can do it all at once or you can do it separately. And I want you to come in with the answer for Friday. We'll compare and make sure you get the same thing here. So pause the video and do that. And we have one more example to do, and then you should be good to go on Friday to work on these in your groups. So again, if you didn't get this yet, pause it, do it on your calculator. Let's move on to the last one, number 4. All right, number 4, once again, is a little bit different than the others because this time I have an area, and it's bounded by this curve, which is sine of x. So we all remember what sine of x looks like. It starts at the origin and goes up, so it would look like that. We're looking at it at the left side, okay? And this time it's bounded by the x-axis. I haven't had one like that yet. And I'm giving you two x values, negative pi over 4 and negative 3 pi over 4. So I'm going from the curve up to the x-axis and in between these x values, which gives me this purple chunk here. So I want you to shade that on your paper. The x values are already labeled for you. And what you need to think here is, okay, what are my top and my bottom curves? You might be thinking there's only one curve here. But look, for this area, my function sine is definitely the bottom curve. So then you might be thinking, okay, well, what's the top curve? It's this right here. It's not really a curve at all. It is a function. The x-axis is the top function, or the top curve here, I guess. And the x-axis, if you wanted to write it as an equation, it will be y equals 0. So it's really important that you remember that because you're going to have to use that sometimes. So I'm still going to do the integral of top minus bottom. It's just this time, the top curve happens just to be 0. So let's set the integral up here. I'll write it a little bit neater this time. And I'm going to do the integral. And I'm going from my leftmost x value to my rightmost x value. And I'm going to do my top curve, which is 0. And I'm going to subtract parentheses. I'm going to subtract my bottom curve, which happens to be g here, which is sine of x dx. And again, this is really just the same as negative sine of x dx because it's just 0. So go on your calculator and find the integral of that. And we'll compare answers when I see you next time. Go on your calculator. We're rounding to 3 decimal places. Make sure you're in radian mode, and I will see you Friday.